Hello learners, welcome to our studio of National Institute of Open Schooling. So today we will study about the liquid state. So before starting this topic, let's get familiar with matter. So do you know the meaning of matter? I will tell you. Anything which has mass and occupies space is called matter. There are three types of matter: solids, liquids and gases. Learners, this classification is done on the basis of intermolecular forces and the arrangement of particles. In solids, the particles are tightly packed as shown in figure. The intermolecular forces of attraction is strongest in solids. In liquids, the particles are loosely packed and the intermolecular forces of attraction is quite strong. In gases, the particles are far away from each other and the intermolecular forces of attraction is strongest. In liquid state, the particles are loosely packed and they can flow freely around. That's why liquids are also called fluids, because liquids have the ability to flow. The most common example of liquid is water, and water has the ability to flow. Now we will study the various properties of liquids. First property is shape and volume. Does liquids have fixed shape? Our answer will be no. Why no? Because in a liquid state, the position of particles are not fixed due to comparatively less strong forces of attraction. That's why a liquid takes the shape of its container. If we put the water in a glass, then the shape will be that of a glass. But if we put that water in a bottle, then the shape will be that of a bottle. Next thing is volume. Liquids have fixed volume. But why liquids have fixed volume? Because at particular temperature, the spaces between the particles is fixed. That's why we can say that liquids have fixed volume, but liquids do not have fixed shape. Next one is compressibility. What is compressibility? Compressibility is the ability of a substance to be squeezed or pressed when a force is applied on it. Liquids are largely incompressible because the spaces between the particle is very small and the forces of attraction is quite strong. That's why liquids are incompressible. Let us understand this with the help of an activity. We need a syringe and some water. The first step is we have to take the syringe and fill it with water by pulling out the plunger. Then learners, you have to note the volume of water and then press the plunger while blocking the nozzle of syringe with a finger. Now learners, what do you observe? Does the volume change? No. The volume of water remains the same as earlier. This is because liquids are incompressible. The spaces between the particles are very less. That's why they are incompressible. Next property is diffusion. What do you mean by diffusion? Diffusion is the process of spreading of molecules from the region of higher concentration to the region of lower concentration. So, let us do an activity to understand diffusion. What do you need? A glass, some water, blue ink and a dropper. So, first take some water in a beaker. Second step is you have to put few drops of blue ink into the water with the help of a dropper. Third step is now leave the beaker undisturbed for few minutes. After some time, what will you observe? You will see that the blue ink spreads slowly into the water molecules, and after some time the colorless water turns into a blue solution. Why it happens? Because of the property of diffusion. The particles of ink mixes with the particles of water. So, learners, you learn that liquids show the property of diffusion, but the rate of diffusion is quite slow in case of liquids. Now, our next property is evaporation. Evaporation is the process of changing of a liquid into its vapor phase or gaseous phase below its boiling point. So, liquids show the property of evaporation. In a liquid, at any temperature, a small fraction of the molecules is moving with relatively high velocity. Such molecules have high kinetic energy. These molecules overcome the forces of attraction present in the liquid state, and they break the forces and changes into vapor phase. As shown in the diagram, the surface of liquid state, the molecules are having higher kinetic energy as compared to the lower surface particles. So, due to high kinetic energy, the molecules break the forces and moves apart and changes into vapor phase. There are some factors which affect evaporation. These factors are surface area and temperature. If we increase the surface area, the rate of evaporation will also increases. For example, for faster drying of wet clothes, what will we do? We will spread our clothes so that the surface area will also increase and the clothes will dry soon. The next factor is temperature. When we increase the temperature, the rate of evaporation also increases. Why it increases? Because when we are increasing the temperature, then we are supplying heat. So, when the molecules absorb the heat, the kinetic energy also increases and the molecules start moving fastly, and they will break the intermolecular forces of attraction and move apart. You will see this in your daily life. For example, the wet clothes dry faster in sunny days as compared to cloudy days. So, our next topic is vapor pressure. Vapor pressure or equilibrium vapor pressure is the pressure exerted by a vapor in its condensed phases like solid or liquid at a given temperature in a closed system. As shown in the diagram, in first figure you can see initially evaporation of liquid starts. In second figure you can see condensation begins, and in third figure you can see there is equilibrium between the rate of evaporation and condensation. Vapor pressure of a liquid has a characteristic value at a given temperature. For example, vapor pressure of water is 17.5 torr at 20 degrees Celsius. Vapor pressure of benzene is 75 torr at 20 degree Celsius. So, at equilibrium, the rate of evaporation and the rate of condensation become equal. It means now further evaporation does not occur and the equilibrium become constant. Students, you have studied earlier that by increasing temperature we are supplying heat energy, and by absorbing heat energy the particles of liquid state are able to move freely by breaking the forces of attraction between the particles. Next topic is boiling. As we have seen practically, when we heat liquid, there is formation of bubbles at the base of a vessel. After some time, bubbles of liquids are formed throughout it. This is boiling of liquid. A liquid boils at a temperature at which its vapor pressure is equal to the pressure of gas above it. So, learners, you are able to define boiling point. Boiling point is the temperature at which the vapor pressure of a liquid is equal to 1 atmosphere, that is 760 torr. So, learners, let us compare evaporation and boiling. So, I think you are able to differentiate between these two phenomena. So, I will tell you evaporation. The first thing is evaporation occurs at all the temperatures, but boiling occurs at a particular temperature. For example, the boiling point of water is 100 degrees Celsius. Second point of difference is evaporation is a slow process and boiling is a fast process. So, learners, I think you are able to tell the various properties of liquids which we have studied. So, let us recall. First one is shape and volume. Liquids do not have fixed shape, but they have fixed volume. Second one is liquids show the process of diffusion, means liquids are able to move from the region of higher concentration to the region of lower concentration, but it occurs slowly. Third one is evaporation. Liquids show the property of evaporation, and the last one is boiling. Liquids are able to boil. So, learners, if you have any queries, you can contact our email address or telephone number. Hello learners, welcome to our studio of National Institute of Open Schooling. I am Pinky Negi, your science teacher. Students, in your previous class, you studied about the various properties of liquid state, like liquids have definite volume but no definite shape. Liquids show the property of diffusion, evaporation, boiling, etc. So today we will study about the surface tension and viscosity. These are the other two important properties of liquid. So first one is surface tension. So students, what do you mean by surface tension? Surface tension is a force acting on unit length of a line to be drawn on the free surface of a liquid. So students, look at the figure. In this figure, a line is drawn on the free surface of the liquid and surface tension is acting upon these lines. So these lines are imaginary lines as shown in the figure. So we can say that surface tension is equal to force upon length. Surface tension is a kind of force which is acting upon per unit length. As shown in the figure, surface tension force acting on free surface of the liquid at rest. The molecules in a liquid state experienced strong intermolecular attractive forces, and when these forces are between the like molecules, they are called cohesive forces. For example, the water droplets are held together by strong cohesive forces because the water droplets are like molecules. So these cohesive forces actually constitute surface tension. Students, now we will study about the various effects of surface tension which you will observe in your day-to-day life. First one is spherical shape of liquid droplets. A liquid drop has a natural tendency to form spherical shape. This is due to surface tension. The tension tends to reduce the surface area of the liquid to its minimum, and a sphere is the shape with minimum surface area at a given volume. So students, look at the figure. As you are able to see in the figure that a spherical shape of liquid drop is due to surface tension. Now next one is wetting and non-wetting properties. So before starting this topic, wetting and non-wetting properties, you must know what is angle of contact. So angle of contact is defined as the angle enclosed between the tangents to be drawn on the liquid surface and the solid, both inside the liquid, and the tangents to be drawn at the point of contact of the liquid with the solid. So students, look at the figure, figure A. In this figure, water is taken in the tube. As you will be able to see, the tangents are drawn at the solid surface, means the surface of the container, and second tangent is drawn to the liquid surface, that is drawn towards the meniscus, and this angle form is called angle of contact, which is denoted by theta. So as you are able to see, theta is acute, it is below 90 degree. So those liquids which form angle of contact below 90 degree, that is acute, they always form concave meniscus. As shown in the figure, the meniscus is concave in nature. So the liquids which form concave meniscus and angle of contact is acute, those liquids are wetting in nature, means those liquids will wet the surface of the container. For example, water in glass. Water is a wetting liquid. It wets the surface of glass. Now students, look at the figure B. In this figure, mercury is taken in the tube and angle of contact is drawn at the liquid surface and towards the meniscus, that is convex in case of mercury. So students, what will you observe? Angle of contact is obtuse in case of mercury, means it is greater than 90 degree, and the meniscus formed is convex in nature. So the liquids which form convex meniscus and angle of contact is obtuse in nature, those liquids are non-wetting, means those liquids will not wet the surface of the container. For example, mercury and glass. If you will take mercury and the glass, the mercury will not wet the surface of the glass because mercury is non-wetting liquid. So students, I think wetting and non-wetting is very much clear to you. Now, wetting and non-wetting properties are due to two kinds of forces. You must know these forces. First one is adhesive forces and second one is cohesive forces. So students, let's discuss about these forces. What do you mean by adhesive forces? These are attractive forces acting between the molecules of different substances. For example, water wets the surface of glass due to strong attractive forces of adhesion between water molecules and glass molecules. So students, look at the figure. Water is attracted to other substances like glass due to adhesive forces. Now next one is cohesive forces. Cohesive forces are again attractive forces, but these forces exist between the like molecules. For example, solids have definite volume and definite shape due to stronger forces of cohesion. In case of liquids, the cohesive forces are quite weaker, and in case of gases, it is weakest because gases do not have fixed shape and fixed volume. If adhesive forces are stronger than cohesive forces, then the liquids are wetting in nature, and if cohesive forces are stronger than adhesive forces, then the liquid will be non-wetting in nature. So students, I think wetting and non-wetting properties and cohesive and adhesive forces are very much clear to you. Now let's start another topic, that is capillary action. Capillary action is the ability of the liquid to flow in narrow spaces without the assistance of or in opposition to external forces like gravity. So to understand this capillary action, let's do an activity. So requirements are 2 beakers, 2 capillary tubes, water and mercury. So students, what is the procedure? Procedure is, in one beaker, take some water and immerse one end of capillary tube in it. In other beaker, take mercury and immerse one end of other capillary tube in it. So students, what do you observe? When one end of a capillary tube is immersed in water, it rises, while in case of mercury, it falls. This is capillary action. A liquid which wets the surface of the container shows concave upwards meniscus, and the liquid which will not wet the surface of container shows convex meniscus upwards. Students, there are some common examples of capillary action which you will observe in your day-to-day life, like A towel soaks water on account of capillary action, swelling of wood in rainy season, and oil rises in the long narrow spaces between the threads of a wick because they act as fine capillaries. So, I think capillary action is understood to you people. Our next topic is viscosity. As you all know, every liquid has the ability to flow. Some liquids like glycerol or honey flow slowly, while others like water and alcohol flow rapidly. This difference is due to internal resistance to the flow of liquid, and that internal resistance is called viscosity. When any liquid flows steadily, it flows in different layers, while one layer sliding over the other. Such a flow called laminar flow. So, students, look at the figure. It is called laminar flow, having different layers of a liquid. Due to intermolecular forces of attraction, each layer experiences a force of friction from its adjacent layer. This force of friction depends upon area of contact between them, which is denoted by capital A, distance between the layers, which is denoted by dx, difference in velocity between the layers, denoted by du. This force of friction is equal to minus sign eta A du upon dx. So, F is the force acting between two layers, eta is coefficient of viscosity, and the negative sign indicates that the force is acting opposite to the direction of motion of the liquid. In CGS system, the unit of coefficient of viscosity is poise. The SI unit of coefficient of viscosity is Pascal second or decapoise. So, learners, you have learned about the different properties of liquid states, and I think it is very much clear to you. So, if you have any queries or any doubts regarding this topic, you can contact
हिंदुस्तान के हर कोने में नौजवानों के पास प्रतिभा है, उन्हें अवसर चाहिए।
NIOS देता रहा है युवाओं को अवसर आगे बढ़ने का। NIOS से पढ़ने वाले इन युवाओं ने किया है संस्थान को गौरवान्वित। दिव्यांगों ने बन के दिखाया है सबल और आत्मनिर्भर NIOS के साथ। आप भी जुड़िए NIOS के संग।